pressure, force, and area is what we're looking at in this video. It's split into 4 parts. So first, we're going to start off by looking at simple questions like this, where the units are consistent. Then we're going to look at examples like this, where we need to do some unit conversion first. And then we're going to look at questions where we've been given the volume and we need to find the cross-sectional area. And as usual, we'll wrap up by looking at an exam question, and that's this one here. So the way my videos work, I'm going to do the example on the left, which is I do. You are then going to press pause and have a go at the example on the right, which is you do. So here, if you've been asked to work at the pressure. So the formula for the pressure is force over area. So the force here is 300 newtons, that there. And the area is 150 centimeters squared. And if you just divide the two, you end up with 2 newtons per centimeters squared. That's your units for that. So hopefully you've pressed pause and had a go at the example on the right. So exact same approach. Pressure is force over area. The force is given as 160 newtons. Now with the area, we've been given the width and the height, and we've been told it's rectangular. So to find the area of a rectangle, it's just going to be width times that. So that gives me 80 centimeters squared. So now I have the area, and it's the exact same. So 2 newtons per centimeter squared is the answer here. So here's some practice questions. Press pause now and have a go. Here are the answers. Mark your work. Moving on. So there's a little confusion that pops up when people look at conversion of, this should say squared. So let me just correct that quickly. When people look at conversion of pressure units, so that should say squared. So to convert from 12 meters squared to centimeters squared, so 12 meters squared to centimeters squared, all we're doing is multiplying by 10,000. Okay, so that becomes 12,000 centimeters squared. Well, not 12,000, it'll become 120,000 because you'll end up with 4 zeros. Now, when people come down here and they think, well, actually, how do you go from newtons, so a pressure of Newton meter squared, to Newton centimeter squared, people think, well, actually, it's the same thing because you're going from meter squared to centimeter squared, so surely you just times it by 10,000 as well. And that's not right, okay? What you do not multiply this by 10,000. In fact, the correct answer here is you divide it by 10,000. Now, it's important I address why that's the case. So remember, pressure is force over area. So I can write this as force over area. So what I've just done is I've rewritten this, which is the pressure, which is force over area, like this. Now that I've written it like this, I need to convert this to centimeters squared. So the top part is fine. We don't need to touch that. Now the bottom part, we multiply it by 10,000. So we end up with this. And now what we're saying is, well, actually, the answer is 12 divided by 10,000. And you can sort of see where that 10,000's come from then. So you hop it 4 times newtons per centimeters squared. Okay, and that is the reason why you divide, because you want to write it out like this. So moving on, here's some practice questions. So again, with this, we want to look at writing it as a fraction first. So we have 7 newtons per meter squared. You want to convert that to centimeters squared. So we have 7 newtons can stay. The bottom, you multiply it by 10,000. So 1 meter squared becomes 10,000 centimeters squared. And then you just divide the 7 by 10,000. So that'll be 7 newtons per centimeter squared will become your answer there. And at the bottom, again, exact same thing here. So we have newtons over centimeters squared. But this time we're going to meters squared. So the top part stays the same. So we have 11 newtons. That doesn't need touching. The bottom part, we are dividing by 10,000 now. So to go from 1 centimeter squared to meter squared, you divide that by 10,000. And I've added an extra one there. So that becomes that per sort of meter squared. And if I do 11 divided by 0.0001, I end up with 110,000 newtons per meter squared. Okay, so hopefully that's clear. So hopefully press pause and have a go at this. So again, I would recommend you write this out as a fraction. Newtons per meter squared. The top part can stay the same. The bottom part, you just multiply that by 10,000. And now you just do 9, divide that by 10,000. Then you end up with 0.0009 newtons per centimeter squared. And here we have 16 newtons over 1 centimeter squared. So that's this bit here. And then we can convert that. So the newtons stay the same. The bottom part, we divide that by 10,000, and that becomes that, which then becomes 160,000 newtons per meter squared. So moving on here, we can see the units don't quite match up. So the pressure, they want in centimeter squared, but the area is given in meter squared. So if you want to convert something, it's probably easier if you just convert this. So how do you go from meter squared to centimeter squared? You just times it by 10,000. So if I times that by 10,000, that becomes that. So the pressure is force over area, which is 200 divided by 200 in this case, which becomes 1 Newton per centimeters squared. So hopefully you've pressed pause and had a got the example on the right. This should really be a power of 2. So with this one, we have a square base. So given that it's a square, you know, the base and the height are going to be the same. So remember, pressure is force over area. The force is not a problem. Now, with the pressure, if I compare the units, this is in centimeters squared, that's in meters. So I want to convert the 4 meters to centimeters. So that can just be times by 100. So that's going to be 40 centimeters. And so the area is just going to be 40 times 40, which becomes 1600 centimeters squared. And then I can put that in here and then just do 640, divide that by 1600, and that gives me 0.4 newtons per centimeter squared. So here's some practice questions. Press pause now and have a go. Here are the answers. Mark your work. Moving on. So here we've been given the volume. So if we know the prism has a height of 4 meters, it has a volume of 20 meters cubed. The pressure is given as well. So it's saying work out the force. So the force is pressure times area. We know the pressure is 15 newtons per meter squared. Times that by the area. Well, what is the area? So to work out the area, we know that the volume is the cross-section area times the height. Now we have the volume, which is 20. So we know 20 is equal to the cross-section area times 4. So we know that the cross-section area is going to be 5. So we can replace this for 5. So you just do the volume divided by the height, and you get that. And then you just do 15 times 5, and that gives you 75 newtons as a final answer. So hopefully you've pressed pause and had a good example on the right. So we've been asked to find the force, the pressure is 10 newtons per meter squared. Times that by the area. So what's the area going to be? So that's just remember the volume, divide that by the height. That gives us a 6. So that would just be 60 newtons. So here's some practice questions. Press pause now and have a go. Here are the answers. Mark your work. And now we're looking at an exam question. So here we've been given some details on the force, the pressure, and it wants to know, it's a rectangle, it wants to know its width. Okay, so we have the area is what we want to find. So the area is force over pressure, which is 180 over 187.5. The units all look fine to me. There's no need for any unit conversion, so we're working in meters all around. So if I do that, I end up with 0.96 meters squared. So we know that 0.96 is equal to 1.2 times the width, which is x. So if I divide that by 1.2, I get x as 0.8 meters. So if you would like some more practice on this, I've got a full worksheet linked down in the comments below. And if you find this video useful, I've got loads of other content like this, do check it out.